Hello and welcome back everyone to what is still the first live session of the 7th International Electronics Conference on Sensors and Applications, also known as ECSA-7. This conference has been organised by MDPI and the journal Sensors and Chemosensors, and I would like to thank all the speakers and all the participants for joining us today. From today and up until the 30th of November, you'll be able to read and comment all the authors' submissions presented for the conference and also enjoy some live sessions. In order to do this, please take a look at our webpage for more information. I would also like to remind everyone that this webinar is being recorded and that it's also being live streamed on YouTube, and the recording will be posted as soon as possible on the webinar's webpage for everyone to watch. And now, without any further ado, I hand the floor over to Stefano.
Thanks, Charlotte, for the introduction. So I just add a few words to introduce our keynote speaker today, Benedetto Vigna. I think most of us already know Benedetto, but just to introduce him, so he is president within STMicroelectronics of the analog, MEMS and sensor group. And he is also a member of the executive committee of STMicroelectronics since 2018. So I just wanted to say it's a great pleasure for me to introduce today his keynote speech related to, as you see, sensors enable next wave of artificial intelligence. So Benedetto, thanks for being with us, and the floor is yours.
Thank you, Stefano. Thank you. It's really a pleasure for me to be here. I would have been preferred in physical person, but we all live this digital experience. So what I will do in this speech, I will share with you what is our view about how sensor can enable the next wave in the artificial intelligence. Sensor and artificial intelligence are definitely words that are more and more known, especially to you, because this is ECSA conference, but I would like to provide my point of view, that is the point of view coming after putting on the market a lot of sensors and a lot of actuators. I put here this chart that is showing what STMicroelectronics did in the last 15 years. We put in the market, as you can see here, different kind of sensors, different using different principle, capacitive or optical. And here you see some of the numbers. We put on the market more than 1 billion time of flight sensors. We put on the market more than 5 billion microactuators and almost 20 billion MEMS sensors. And it's a pleasure to see in this conference some people, some colleagues that we were working with already 20 years ago when we were doing some measurement in the laboratory in Pavia with for the first gyroscope of ST. At that time, we were not on the market. Now, some time has gone and we put a lot of sensors on the market. In this speech, I would like to touch 3 topics. Number 1, how sensors fit in the semiconductor industry. Number 2, which are the trends in the sensor industry. And number 3, how 3 words, IoT, augmented reality, and artificial intelligence fit all together. Let's start giving a look at what is the market of sensors. I asked Omdia, this research company, to provide me their latest numbers about what has been the market, let me say, when we started these adventures. It means 2006, and how the market is going to evolve in the next years. So I got here an interesting chart, and I wanted to share with you, because here you see how the sensor market evolved since 2006, and how it's going to be in 2024. So it was more or less $2.6 billion a few years ago when the MEMS adventure started, with a dominance of some sensor, as you can see here, mostly accelerometer, and magnetic. And then in 2024, instead, the pattern is going to be different. The market is going to be around 10 billion sensors with more balanced rainbow. You see here that you have colors representing different kind of sensors. And obviously some sensors that in the past were small, like for example, the microphone or the gyroscope, are becoming definitely bigger. So this is today one of the small, how can I say, board reference design that you can find on the market. I took one obviously from ST. This is a wireless sensor node. This is a small node, the dimension of a coin, that contains in it any sensors that you have seen in the previous chart. And you can connect and collect this data thanks to a Bluetooth connection. So this is, I put this chart because I want to show you that in the last 15 years, something that in the past was going to be bulky, expensive, very power hungry, today is available in a very small form factor. And here, our company, together with all universities, we work together in Italy, in Europe, in Japan, and in US, helped us to make it possible. But let's see a little bit what happened in the semiconductor industry in the last 60 years. Because semiconductor industry is relatively young. It's an industry that I think we can say that in this industry we saw two main revolutions. In the first revolution, okay, we have been mimicking with transistors what are the function of the brain, of the power of the human beings. So we start to put on the market memory, power chips, a processing unit. In the second revolution, instead, something that started in the 80s, we started to have the so-called the second, the sensor revolution. Basically, in the silicon, we started to see resistors, variable resistor, variable capacitors, photodiode that were used as the input stage of semiconductor sensors. And why sensors are important? Sensors are important, in my opinion, because in this journey of artificial intelligence, with the sensors, we can move from the current stage of artificial intelligence, that is basically business artificial intelligence, to what is called sensing artificial intelligence, and then autonomous artificial intelligence. Why I say this? Because a lot of time together, either you refer to recommendation that you get through engine on the web, through search engine, or internet can get better because they study better our behavior, or the use of algorithm. In any case, you have data that are entering the network because of keyboard, the touch screen, or mice. When you have the sensor instead, the amount of data that you will have available on the network, on the digital space, will increase substantially. So that's the reason why I say sensors, by bringing all this data of the real world in the web, on the digital space, will enable this quantum leap from the business AI to the sensing AI. So let's see what happened in the sensors, because sensor, as I told you, started in the 80s, in the second, so-called the second revolution of semiconductor industry. And the sensors were mostly used in car for three main reasons: safety, green, and comfort. The sensor we were using were at the beginning pressure sensors for improving combustion in the car. And then we had also sensor for basically improved safety, sensor for airbag or fair vehicle dynamic control. And then later, we had also magnetic sensor for ABS. This was before year 2000. If we go to the first decade of this century, then basically we see different kind of application. So we see sensor for new gaming experience, and sensor that go from, that transform the phone in smartphone. What do I mean by this? Let's see what happened in May 2006. This was an important date for all the sensors, because it was the time when Nintendo launched its game console that was using sensors to simplify the way people deal with the game console itself. This was a big decision taken by the CEO of Nintendo, and we, ST, we were able to support the growth of this new game concept for an easier user interface. So in the first decade, we had this gaming revolution in the gaming console, but we also had another important revolution in the phone industry. In the phone, if you remember, at that time, the number of sensors was not so big. It was a phone mostly used to make phone connection and also to do some texting. But then we start to see some phone, either from Nokia or from Apple or from Fujitsu in Japan, where the number of sensors in the phone itself increased. So we start to see touch screen sensors, CMOS image sensor, but also accelerometer. And then this was the case of 2007, when accelerometer was mostly used for image rotation, but then later it started to be used also for example for gaming, more complex, that were using the input of the gyroscope. So this was the first decade. Let's now go to the second decade, the decade that started in 2010, 2011. In this case, we had the emergence of a different kind of sensors. It was the case of sensors that were using mostly, I would say, infrared light. We had some false start, like the infrared sensor coming, the system proposed by Intel for 3D scanning and 3D printing. This was the system that was proposed in computer for new application, and it was not so much successful. Instead, in the same years, we had another system that was mostly used for face recognition. This was the year 2017, when the company started to use the 3D and depth sensing, for example, for face recognition in the mobile phone. This is to replace the fingerprint with the face recognition itself. So this is the second decade. First decade, mostly consumerization of MEMS. Second decade, some false start, some successful start. And here we are, 2020. We are entering the third decade. And I want to show you what we see on the market today. Because on the market today, we see more and more sensors that are used for industrial application. So today, sensors are used for example, for asset tracking, are used for real-time monitoring, are used for predictive maintenance, and also for metering of important resources like electricity, like gas and water. So I remember a few years ago, and I remember well when we were doing, we were small in the field of sensors, there were already a lot of academic papers talking about the adoption of sensor for this application. But at that time, the business was not yet there. The business was small. The business is becoming bigger now, and you can read for sure on internet. There are many activities addressing different kind of application, but the application that are really becoming more relevant from a business point of view for all the players of the ecosystem are really clustered around these four names: the tracking of the asset, the monitoring real time for important asset, the maintenance, the predictive maintenance to avoid to have a line down in manufacturing line, and also the metering of electricity, of gas and water. This is becoming a fact in the third decade. And I think really when we look at the sensors can help to control the equipment from the time they are shipped to the end of life after the operation. Here I put one example. Suppose that, for example, you want to ship an engine to be installed in a factory. Well, you can install a sensor in the boxes that can tell you if where are the sensors, where is the good, where is the asset. You can also understand if the asset was experiencing a lot of shocks or not. Then they can help you to install the equipment properly, because it may happen that, for example, the engine is not properly installed for whatever reason. There are some cases where, for example, the engine is not placed in the right position, thus the lubricant oil is not doing the job properly. So the sensor is telling you how to mount the engine in the right way. And then there is the case of operation. When the engine is working, you may have problems because the bearings are not working as they are supposed to work. And in this case, you have the possibility to intervene on time to avoid line down, so waste of money for the owner of that factory. So this is one, I would say, the decade where the sensors start to enter, to move from the consumer space to the industrial space, and consider that in the factory of the future, for example, the robot and the human beings will be closer and closer. They will work closer and closer. The name of cobots is becoming more and more common. So here, the sensors are important because they have to control the way the sensor, the equipment, the machine are working when they are close to human beings. So really, this is the decade of the sensor in industrial world, and also the decade where we see an increasing pervasive of sensors in the structural monitoring of critical assets. We're talking about tunnels, dams, we're talking about windmills, bridges, but also we're talking about some cases like the elevators. There are companies that are looking to sensorize more and more the elevators to make them smarter. So when we had the first sensor that were mounted in the Nintendo Wii console in 2006, 2007, some of our partners in the Politecnico as well of Milan were using our sensor to monitor the vibration of the stadium, of the football stadium in Milan. At that time, these sensors were good, but the power consumption was really too high. It was too difficult to imagine this sensor to be battery operated. Now, instead, the sensors are reaching the limit, the power consumption that enable them to be battery operated and to address this kind of application that once were only, let me say, existing on the paper. But sensors, if they are used to monitor physical asset, physical stable asset, they are also used more and more. We see that sensors are becoming more and more pervasive in the monitoring of life signal of human beings. There are cases where there are patches that are full of sensors, and some of them are connected with different kind of radio, Wi-Fi or Bluetooth. They are connected to the mobile phone, and then through the mobile phone they reach the cloud. In this way, you can have a kind of remote monitoring of live signal. So this is really a way how the sensor itself are becoming more and more spread in the industry and are helping us to bring to this, to what I call the third step in artificial intelligence. But we see also today some other technologies that once were conceived only for augmented and virtual reality that are entering in new kind of application. Here I put an example of product, how they can be used in industry and healthcare world, apart from the entertainment. Here there are some small, tiny MEMS mirrors, can help people to deal with new services, and they can work and socialize in a different way. So imagine, for example, you are a fab manager and you want to optimize the layout of the equipment once the plant is complete. Well, augmented reality glasses can help you to visualize it well in advance. Imagine that you are making a surgery and you have to remove something unpleasant from human body. With augmented reality glasses, you can understand what is the part that you have to remove effectively. So the application, there is a kind of, I would say, movement that is bringing the sensor, once conceived for consumer space, also to industrial space. Recently, you may have seen these two announcements. These are two announcements where there are the mirrors that the ST team did. These are two, one is coming from Microsoft, it is called HoloLens 2. One is coming from Intel, it's called RealSense. This is the different from the RealSense application of the second decade that was embedded in the PC that was not so successful. This is a standalone device. In this case, and you can Google these two links, in this case, there are some small mirrors that are done by us that are able to scan and to reproduce, to scan the environment or to reproduce an image. So here we are talking about mirrors that are in the dimension of a few millimeter diameters. We can have cases of one-dimensional mirror or two-dimensional mirrors. And these are actuated with electrostatic or electromagnetic forces. These are products on the market that can be used also, as I told you, in industrial space for robotic navigation, for measurement of the dimension, because, for example, for a shipping company, take Amazon or DHL, when you ship a good, you pay based on volumetric space and the volumetric weight. The volumetric weight, you have to measure also the dimension of the box. In this case, with a device like the RealSense one, you can measure easily. At the core of this application, there are our MEMS mirrors. But there are also new application in the car. As I told you before year 2000, the sensors were already used in the car for different purposes, mostly green, safety, comfort. But today, the cars are becoming more and more autonomous. Take the case of ADAS system, where in this case, you have sensors that can help the car to move better in the future. This is the case of a sensor that enable the LiDAR. The LiDAR is very important because it helps to provide additional information for the proper navigation of the car. The LiDAR today, however, is too expensive. And thus you need something that is cheaper. To make it, the MEMS mirrors are a way to move forward. And in this chart, you can see what ST did basically a few months ago. We announced the partnership with a Canadian company called the LiDAR-Tech. Here we want to develop, to bring to the market a small MEMS mirror to reduce the cost of a LiDAR. Today, the LiDAR is too expensive. If you put all the LiDAR you need for autonomous cars, you would end up paying more or less the same amount of money for LiDAR as well as for the rest of the car. So here, the challenge is to make this LiDAR cheap enough, keeping the performance and the reliability that are required by challenging application like the one of autonomous cars. But now that we have seen this application, what is going to be required in the future, which are the features that the sensor must have? I would like that there are underlined three words: accuracy, low power, and connectivity. Let's go to see a little bit which are the sensors for Industry 4.0. Imagine you have an engine in a factory and you want to do machine diagnostic. Well, you need to have the input from different sensors. You may have an accelerometer, a microphone, a pressure, a temperature. This sensor data must be put together, and then they have to go through a connection with wire or without wire. They have to reach the cloud. Once they reach the cloud, you can do several things like the digital twins or the cloud analytics. But to do this, you need the sensor data to be accurate. So one of the drivers of the roadmap of the sensor development is to increase the accuracy. The accuracy increase in sensing when you detect the measurement of the external world, but also increasing the accuracy in the processing of the sensor itself, of the signal itself. And also, you need to do this at very low power. You cannot waste a lot of energy for the sensing or for the processing. You have to be optimized. Once you do this, then you have to connect. And as I said, you can connect with wireless standard like Bluetooth, Wi-Fi, Sigfox, but you can also connect with a wire, with a standard that are more typical of industrial world. I'm talking about, for example, IO-Link or in domotic environment with KNX. I would like in this sense to put the accent on something that is pretty well, I mean, very much heard in the industry, but something that is specific of the low power processing of the sensor. Today, a lot of times we hear about artificial intelligence run in the cloud, in the server. And then you have artificial intelligence run at the edge of the cloud. It means that you have locally, you have a microcontroller that is taking the input of the sensors, processing and transmitting to the cloud. What I see as a trend is the need to have sensors that are autonomous and that are able to process the data inside without, so that they do not transmit only raw data. They do not transmit data to be processed. They transmit already processed information. And this is what I call AI at the edge of the edge. It's in-sensor computing that we did, and we are doing already with several sensors we put on the market that embed the machine learning algorithm. So this is a technique. This is a way to reduce the power consumption of the sensors from a factor 10 to even a factor 1000, depending on the use case. So a practical example, you have a sensor on a machine that is, let's say, moving, that is working. There are two ways to do predictive maintenance. You transmit all the data to a microcontroller, and then after the processing, they go to the cloud. Alternatively, the sensor itself is smart enough that is the processing, it's happening locally, so you do not have to wake up and to waste a lot of money, a lot of energy, sorry, with the microprocessor or microcontroller that you have locally. This is, we have put on the market this kind of sensor, and there is really a lot of traction. It's really, really important. The AI at the edge of the edge, for the sensing, for the third wave of artificial intelligence, the sensing AI is becoming more and more important. So now you understand that the graph that I put at the beginning of the presentation, we need the sensor to move from a business AI to sensing AI and autonomous AI. Autonomous AI, it's a case of autonomous cars. Because when you have sensors, you see basically the online world and the offline world, the digital world and the real world merging together and becoming, let me say, becoming cloned for many different operations. And I would like here to explain a little bit more in detail the relation between IoT and augmented reality. So let's see a little bit how does it work in industry without sensors. You have an equipment, machine, you have human beings, and then you have a cloud. When you have an equipment, usually the equipment is not connected, is by itself. You may have some, let me say, software download upgrade from the cloud when the human beings are giving clear instruction. And you have also human beings that are instructing and moving some physical knob on the machine itself. This is the past. Where are we moved? We are moving to a situation like this one in the pictures. A situation where there are sensors and there is artificial and augmented reality. And the two, IoT, enabled by sensor, augmented reality, they work together. In which way? Let's look now at the same three blocks as in the previous chart, but with different eyes. On one side, you have the equipment, a smart connected machine. What does it mean? It's a machine with sensors. On the other side, you have a human being that is accessing the data through augmented reality devices. In the middle, you have the cloud. So let's see, you have a machine. It is transmitting all this sensor data flow to the cloud. In the cloud, you have the digital copy of the machine, and also you have all the analytics. Because of all this analytics, because of, let me say, of the data that is getting, the cloud itself can run autonomously some remote control and optimization of the smart connected machine. You can optimize the working point of the machine, and this decision can be taken by the cloud itself. On the other side, there is human being that can use an existing device like a mobile phone, or can use some specific devices like augmented reality glasses. In this case, through this tool, the person, the human being, can interact digitally with the digital twin on the cloud. It can also give instruction through the, let me say, through the cloud. In the same time, the cloud allows the human beings to monitor remotely what's happening. I think the best way to conceive this is to compare ourselves when we get instruction in a car from a mobile phone that contains the map, and instead versus an head-up display. When you have an head-up display, you superimpose the digital information on the reality, and it's much easier to drive. In this sense, really, the augmented reality, thanks to IoT, the Internet of Things, boosted by sensors, can merge the digital, can fill the gap between the digital space that intrinsically is two-dimensional with the reality, the analog world where we live, that is three-dimensional. And augmented reality is enhancing the sense that our human sense, the sight, that out of the 5 senses that each human being has, is the one that brings more data inside our brain. 80% of our data in the brain are coming from the sight, sense, and it's important that augmented reality, by overlaying a digital layer on top of reality, it helps to simplify the way people deal with the reality. In this sense, IoT and augmented reality, what is ST doing, and what is the contribution we are bringing in this respect? When it comes to machine, we want them to be connected, to be sensorized, and here we are building, we put on the market some very useful boxes, development boxes, that we call SensorTile.box. You see also here on my background. These are devices, boxes, that can be easily connected. They can be attached, for example, to a machine or to, let's say, the device that you want to sensorize. And this is one of the devices that we see a lot of traction, and very useful for engineers, scientists. They want to understand more what's happening on the machine, on the world. On the left, on the right instead here, you see what we are doing for these augmented reality devices. We are developing some mirrors that are not anymore electrostatic or electromagnetic. They are piezoelectric, so it means they are very fast. This is very important for the resolution. And here we are talking about also, we set up an alliance. We call it the Laser Alliance, because we want to make sure that this augmented reality becomes dream becomes a reality. Okay, so this as 15 years ago we were pioneers in the MEMS world with the sensors, and with the right customer we were able to reach all these billion sensors we put on the market. The same thing we want to do with the piezo mirror, and we want to do this in the frame of an alliance that we stipulated a few months ago. But if I make some focus on the SensorTile.box, and this is an important chart, I would like to say that the SensorTile.box that we put on the market is a device that allows any entrepreneur, any startup, or any engineer, any scientist to bring the data to the 3 most common cloud in the world. I'm talking about Microsoft Azure, AWS, and IBM Watson. So basically, this data can reach the cloud, and once there, you can have your digital twin that you can access through your digital glasses. I think so far I've been talking mostly about what can be done on the technical side. What must be done to address the need of this third decade where sensors are becoming more and more common in the industrial world. Before to leave this presentation, I would like to address a couple of final remarks about all the sensorization and the link with the artificial intelligence. Is sensor artificial intelligence, like all the technologies, they have double face, good one and the bad one. It depends what is the use that you make of this technology. for sure, artificial intelligence is something, is a set of technique that is mostly looking at optimization of processes. Is also something that can run on its own on computer. So I would say is pretty much antisocial. Okay, and that's the reason why in this diagram you see the AI box in the bottom of this graph, antisocial and optimization based. On the other side, instead, there are the human beings that are more in favor of creativity, strategic based decision, that are more social by definition. Though in this period of COVID, we are limiting our interaction only to the digital space like we are doing now all together. But human beings have also some, I would say, prejudice, some biases that sometimes are pushing us to make wrong decisions. So what we have to do, I think that the best is to, for us, for the next generation, is important that we take the best of artificial intelligence, we preserve the best of human beings so that we can have a real merge of the good of human nature and the good of the mechanicistic approach, deterministic approach of artificial intelligence. Once you put this together, okay, once we have AI for human, at the service of human beings, then we can really benefit. We can really benefit of all the new opportunities that the sensor can enable. We need to make sure really that the AI is at the service of human being. Sensor enable AI. AI must be the sensor of human being. It cannot be the other way around. It cannot be that we are at the service of AI. Because if this becomes the case, then the picture that you see here in this chart can become really a reality where we are working like the slave of the robot. And in this note, on this note, I would like to say thank you. Thank you to all organizers. And thank you also for your time during this presentation. Thank you so much.
Thanks, Benedetto, for the very interesting presentation. Thanks for accepting our invitation, first of all, and thanks for the presentation. So, very nice, very nice. I think that we will have a lot of questions. So I ask people either to raise hands or to write your questions on the chat. So I will give you the floor in order to ask questions. So we are open for discussion now. So what is your opinion on the prospects of chemosensors and biosensor on the sensing market? So maybe if you are able to speak, so if you, so Benji, if you want to ask more or to be more detailed, if you can.
Hi, thanks for your presentation. I was just wondering, so what your opinion would be on the prospects of chemosensors and biosensors on the sensing market on the whole. For example, you mentioned healthcare as one of the rising industries. So what do you think about sensors which are specifically designed to detect for specific analytes, for example, to help monitor health or track disease?
I think, thank you for the question. I think this is very, very important, but I would like to make a difference between chemiosensor and the biosensors. And so the chemiosensor, it's something that we are looking for. I mean, players like us, semiconductor suppliers, but also customers are waiting since a while, but we do not see yet an industrial solution. I remember that one of the first travel I did to a university before year 2000 was to go to meet this professor that had a solution ready to go to the market the year after. It's more than 20 years and the solution does not yet exist. So I would say that the need is there. The need of chemiosensor is there. The solution, however, today do not match the two conditions of price and performances. We have problems of selectivity, of sensitivity, of stability. So today, apart from some announcement of companies that are talking about pseudo sensors, there is nothing on the market. The first one that is able to find a chemiosensor with proper stability, sensitivity, proper performances at the right cost, I think it can make a quantum leap, like we did in the past with MEMS. We have some activities so far with different research centers. We are also open to other ideas, but we still don't see, I would say, the light at the end of the tunnel. This is about chemiosensors. When we talk instead about biosensors, for sure this COVID outbreak is pushing a lot the human beings toward the need to develop biosensors that are able to detect in short time, let's say, the presence or not of this COVID. We did a couple of weeks ago, we announced a device that is a biosensor. It's able to detect the presence of COVID in saliva, in the swab of people, with, let me say, with good degree of accuracy by using polymerase chain reaction. So I would say that the biosensor field, the world is more advanced, and also the world is willing to pay and increase the price for this kind of solution. Are we still at the right level of price? Not yet. Today, imagine if we would have a biosensor with the same response time and the same price of an immunological sero test, that would help us a lot, because the PCR, the polymerase chain reaction, still needs some time. So there is some work to be done. The biosensors are more advanced because you can do these things in specialized lab, but we need to make them simpler to be used and cheaper. The chemiosensor, if you have some ideas, we are more than open to listen and to see if we can do something together. But there is not yet a serious business associated with it. In the chart I presented you before about the market of sensor is in the so-called other. It's, let me say, the ignorance of the market analyst. Let's put it this way. Thank you.
Thanks. Thanks for the question, and thanks, Benedetto. So I saw also Attilio Frangi raised his hand.
First of all, I wanted to greet Benedetto and thank him for his very nice talk. Indeed, when I raised the hand, it was a mistake. I was just playing with the buttons and I clicked the raise hand by mistake. But anyway, I will profit of this opportunity. So Benedetto, apparently you put the accent a lot on piezo devices, especially for mirrors. Do you really think it is going to be as you underlined also in the latest answer, the great new wave?
I believe so, Attilio. I believe because in the past I saw the IoT and augmented reality is a kind of technology push more than market pull technologies. Okay, I saw a few years ago the sensorization of the equipment was seen more like an interesting path only for the company selling the equipment. Instead, this is not true. When you have the sensor, you can make a true digital twin of the equipment that can reside on the web. And imagine, this is nothing more than what I was thinking yesterday, what the scientists did when they sent the first Apollo on the moon. You know, they created a digital twin, another twin. It was not a digital, it was a real twin on the ground to make sure that if something was happening over there, they could intervene locally. I think that the augmented reality, it helps to bring the advantages of the digital world in the real world. And to make augmented reality, you need small glasses, an interface. You need to bring this information to your eyes. And to bring this information to your eyes in a simple way, in a cheap way, you need some MEMS mirrors, and the mirror must be piezoelectric. If you have electrostatic or electromagnetic mirrors, then you have some other problems with the reliability. The manufacturing can be more expensive. The frequency is also limited, so you will lose the resolution. So I believe that for the industry 4.0, you need to bring the equipment on the cloud, thus you need the sensor. But then you need to merge the two reality, the three-dimensional reality of analog world, the two-dimensional of digital world, and thus you need to use the eyes. And for the eyes, you need the mirror, and the mirror must be piezoelectric. I'm convinced about that.
Okay, thank you, Benedetto.
Thanks. Thanks. I see also Alberto Corigliano raised the hand. Okay, I think you can speak now, Alberto, if you unmute yourself.
Good morning, Benedetto. Thank you for your very interesting talk. I wanted to mention what you said about artificial intelligence, which is a very interesting subject also for us. And I wanted to hear your opinion on the following remark. I see the interaction between, let us say, between sensors and AI algorithms as an iterative process. So you can increase the capabilities of sensor with the AI, but you can continuously update your AI algorithms on board in an ideal continuous process of optimization. Do you feel this is a trend in the coupling AI with sensors, or you see it too far from now?
I believe, let's say, a few years ago, we were doing, I would say, dumb sensors that were just collecting all the data, and we're collecting this data and sending to the microcontrollers and then to the cloud, wherever. I believe that if you want to achieve the target of low power, you need this embedded in sensor computing. So I believe that if today you have two areas, the sensor and then the artificial and machine learning core separated, this will become more and more superimposed locally. We cannot work for the sake of power and for the sake of reliability and cost. The sensor on the machine cannot work like, let's say, human sensor in the brain. We cannot have all this data transmitted to the brain. We can have a local, we need to have a local processing brain, like in the case, if I remember well, of Octopus. They have a local brain to process information locally. So I believe in this trend. And I believe also, Alberto, that you will train the network on the cloud, and then you will feed the local neural network in a way to be more, let me say, optimized. But a lot of times we have also to say that there are two kinds of sensors that are sensors like the CMOS sensor, like the microphone, where you have a lot of information. You know, the speech. We have also the optical, or the image processing. For the speech processing and for the image processing, you need very complicated machine learning, deep neural network that must run remotely because the amount of parameters that you have to deal with is very, very big. But for a lot of sensors, take vibration diagnostic, let's say some motion-related signal, the sensor signal is relatively easy. So the network that you have to work on can be relatively easy, and thus embedding the processing locally can help to bring, to make the quantum leap to the sensing AI. I like to make this example, Alberto. When we started with MEMS, I went to see some of the chart that I was using a few years ago. We were saying with the MEMS, you may do a lot of application. But among all these applications, the one that took off, and we see in everyday life, are the applications where the power consumption is the lowest. Gaming interface, I mean, flipping image rotation. There are still some applications that we were mentioning 15 years ago that are not happening because of power consumption. So in-sensor computing will become more and more a must. And I think that this is the way to go.
Thank you. Thank you very much.
Grazie,
Alberto. Thanks, Alberto. Benedetto, Sabina, next.
Yes, Benedetto, I would like from you a message for our students. So among the attendees, there are several students that are at the moment attending the class on MEMS that is running right now in this semester in Pavia. So they are students of the master degree in electronic engineering, in bioengineering, and in industrial automation. So I would like from you a message for them about what they can do in the future to work in this amazing field of MEMS.
It's a good question. I think there is one important message I can bring to them is that MEMS, there is a way to say in ST. The way to say is the following: MEMS are a mess. Why we say this? Because the complexity of the MEMS resides in their simplicity to be understood. I mean, the sense of the physical principle behind the working of sensors is relatively simple to be understood. We are not talking about 3D memory with complex, hyper-complex technologies like the one that you go to buy to the supermarket with, I mean, for the solid-state drive. We are talking about objects that can be successful or not, depending, in my opinion, if you conceive a product that is not nice, a product that is useful. What I want to say is that sometimes for people that are doing scientific and technical studies, like I did, people get in love with the technology, with the most beautiful technology. What is making the difference, in any case in the industrial world, but especially, I believe, for MEMS, is that you need to do something that is useful, maybe is not the best, the most beautiful, but it is working. So the message is, don't get in love with technology, start from the end use and see which are the requirements and how you can fit them in your ideas. This is one point. The second point is more, I would say, in the way you work. Since MEMS are a multidisciplinary topic, you cannot believe to master all the different phases of MEMS. You need to have really a lot of teamwork with people inside your team and the people also outside, because you cannot, it's impossible for one person, two person to master all the different topics of MEMS. And here I have had several experiences where in the past we were trying to fix problem by ourselves, and sometimes simply with a phone call, and this is not a joke, talking with the right people outside your swimming pool, you have been able to fix it. So two messages. Number one, when you conceive a product, start from the end. Don't get in love with the technology, but think to the need that you have to fix, to the solution the customer is asking for. On the other side, on the way you work in a team. You cannot have successful MEMS if you do not work in a team. And if you do this, I think you are also open to see your problem with different eyes. This is the message I would like to pass, Sabina.
Thanks.
Thanks, Benedetto. And thanks, Sabina, for the interesting questions. So we move from the past at the beginning to the future at the end. So we are getting to the end of the session. And so let me thank Benedetto again for upsetting for this very interesting presentation. And I'm pretty sure that there are tons of questions still to be answered. So I invite all the people to go to our website and to use the possibility of chatting with the authors. And in this specific case with Benedetto. So you can send in all the questions using our website. So thanks, Benedetto. Thanks again. And
thank you, Stefano. Thank you all. Have a good continuation.
Thanks. Thanks.
Ciao.
Very interesting. So, and bye-bye. Thanks. Ciao, Benedetto. And so let me say next session for our conference will be next Friday in the morning at 10 a.m. Still Central European time. And so thanks to all the attendees. And so I hope you enjoyed and stay in touch. Use our website to interact with the authors and to see you next Friday for the next sessions. So thanks for being with us.
Thank you. Bye-bye.
Thanks. Bye-bye to everybody. Bye.
Bye.